Alright, in this video we are going to look at some expressions. We are going to simplify them. It's a task you should be familiar with. However, all of our expressions are going to be trig expressions. So we have a lot of trig functions going on here. So the first thing you want to think about is it's going to be very helpful to change trig functions that are not in a form of sine or cosine into that form. So on this first one, I'm going to change tangent to sine over cosine. The next thing I would do here is I'm multiplying two fractions here. So to multiply those, I'm just going to multiply the numerators. So sine x times sine x would be sine squared x, and then my denominator would be cosine x. And then I want to add these two fractions together. So I got to get a common denominator. So I'm going to multiply this fraction on the left by cosine of x on top and bottom. And then that's going to lead me to cosine squared x over cosine x plus sine squared x over cosine x. Now that I have a common denominator, I can add my numerators together. Cosine squared x plus sine squared x all over cosine x. And then what you're going to have to do is look for some identities. So I'm going to pull up this sheet where I have a lot of different trig identities here. One of the most common ones that you'll use is the Pythagorean identity that says cosine squared x plus sine squared x is equal to 1. So this is a very common one that you will use. So that's what I'm going to do. I'm going to replace in this problem cosine squared x plus sine squared x with 1, since that is what that is equal to. So then I just get 1 over cosine x, which is secant x. And we are done. We've simplified that. Okay. So look at the next example. Sine theta plus over cosine theta plus cosine theta over 1 plus sine theta. So what you want to do a lot of times is really think about what it is you're trying to do. So what we're trying to do here is add fractions. And so if I'm trying to add fractions, I need to get a common denominator. And so to do that in this case, I'm going to multiply each fraction by the other denominator. So I need to multiply by 1 plus sine theta on the left and by cosine theta on the right. Okay, so my numerator here, if I distribute my sine, is going to be sine theta plus sine squared theta. And then I'm going to keep my denominator as a product. So I'm going to say 1 plus sine theta times cosine theta. If I multiply what I have on the right, cosine times cosine, that's going to be cosine squared theta. And on the bottom, again, I'm going to leave this as a product. 1 plus sine theta times cosine theta. Okay. After doing that, again, why do we do that? We did that so we can get a common denominator so we can add these together. So now I can add my numerators, sine theta plus sine squared theta plus cosine squared theta all over 1 plus sine theta times cosine theta. Always be on the lookout for identities. So sine squared theta plus cosine squared theta, that's 1. It's the same identity that we used here to say that this was 1. Sine squared plus cosine squared is 1. So I'm going to replace that with 1, which means we have sine theta plus 1 over 1 plus sine theta times cosine theta. At that point, you have this sine theta plus 1 and this 1 plus sine theta. Those are the exact same thing on top and bottom. I can cancel those out, so I replace my numerator with 1. All I have left in the denominator is cosine theta. 1 over cosine theta is secant theta. Okay, it's just a coincidence that we got secant for both of these. You'll get different answers. Sometimes it's just a trig function. Sometimes you may get 1. You get a lot of different answers here, but your goal is to simplify down as much as you can the expression that you start with. All right, number 3, I've got a product here. And there are some different ways you could start this problem. You could change secant and tangent into sines and cosines if you would like to go that route. What I'm actually going to do first is this looks to me like I should FOIL this. And so that's what I'm going to do. I'm going to distribute, multiply all this out. So 1 times secant y is secant y. 1 times negative tan y is negative tan y. Sine y times secant y. I can multiply those together. And then negative tangent times sine, so negative sine y tangent y. Okay. Well, now I can't really see what is going on here. So at this point, I am going to change everything to sine and cosine. So secant is the reciprocal of cosine. Tangent is sine over cosine. And so I'm changing all of those into sine and cosine. Okay, that's going to be a skill that is going to be pretty important when it comes to simplifying trig expressions, is that you change things to sines and cosines, and then you're working a lot with the same trig functions so that you can combine them and so forth. So the next thing that I would do is I would go ahead and take care of these products here and here. Now on this middle, this first one that I put a box around, sine times 1 over cosine, that's going to be sine over cosine. But that sine over cosine is going to cancel with this negative sine over cosine, right? So this and this, those are exactly the same. I can cancel those out. So that leaves me with 1 over cosine y minus, now here if I multiply, that sine's on top, so that's going to be sine squared y over cosine y. I have a common denominator. I can go ahead and combine these into a single fraction. So 1 minus sine squared y over cosine y. And then again, be on the lookout for identities. So I mentioned this, and we've used this cosine squared plus sine squared equals 1, but we can manipulate that expression or that equation to give us some things that we want to look for. So if I were to subtract the sine squared over, I would get this. Cosine squared equals 1 minus sine squared. Likewise, sine squared is 1 minus cosine squared. So there's a lot of different ways to manipulate that identity. And what we have at this point in our numerator is 1 minus sine squared. So I'm going to replace that with cosine squared. Okay, so this 1 minus sine squared is going to become cosine squared. So I have cosine squared y over cosine y, and then I can essentially eliminate one of those cosines on top with the cosine on bottom, leaving us with cosine of y.